In this lesson, we'll take a look at the concept radians, and a radian is another way to measure an angle aside from measuring them in degrees. And at the top of the page is the definition of what a radian is, and it says that 1 radian is the measure of the central angle whose arc length, and central angle means that this vertex in the angle is the center of the circle, whose arc length is the same as the radius of the circle. So in the diagram here, if this is a radius and this is a radius, then the arc length out here is exactly the same amount. This is a radius from here all the way up to here. And so that's the definition of what a radian is. Now in the middle of the page here, we're going to talk about the relationship between radians and degrees, because it's nice to be able to convert from radians to degrees or vice versa. And there's a proportion over here, and this proportion relates to this circle over here. And again, ABC is meant to be a 1 radian angle. So this is a radius, this is a radius. Arc AC would also be a radius length. And so this proportion says that the ratio of the size of this 1 radian angle to the entire circle, okay, that's what this says on the left side, should be in the same proportion as the ratio of the arc length AC, again, to the entire circle. So part of a circle here, a part of a circle's arc length, the whole circle in degrees, the whole circle's circumference. So that's what that proportion says. Now, angle ABC is exactly 1 radian. The whole circle in degrees is 360 degrees. The arc length should be a radius, because this is exactly 1 radian in here. And the circumference formula for a circle says the circumference is 2 times pi times the radius. Now we're going to solve for 1 radian to find out what 1 radian equals in terms of degrees. So the first thing I'm going to do is multiply both sides by 360, so that these 360s divide out on the left side. And we'll get a few things dividing out on the right here as well. For example, the r's will divide out, and that means that this relationship is good for any size circle. It doesn't matter how small or how big the radius is, that this relationship is true. Now also, this 2 will divide into the 360 degrees, going 180 times. And so we're left with then that 1 radian equals 180 degrees over pi. So if I want to find out how big a radian is in degrees, if you take 180 and divide it by pi, you get a little over 57 degrees for 1 radian. This is the exact value though. Now if we multiply both sides of this by pi, 1 times pi of course is pi, pi radians is 180 degrees. So remember, 180 degrees is half a circle, or a half of a revolution, so that's exactly pi radians, 3.14, etc. radians. If we multiply both sides of this by 2, we get the full circle relationship, that 360 degrees, a full circle revolution, is exactly 2 pi radians. And we use this relationship here, that pi in radians is the same as 180 degrees, to convert from degrees to radians and etc. So in example A here, now pi and 180 are the same. Pi is in radians, 180 is in degrees. So I'm actually multiplying by 1. So since I'm multiplying by 1, the 60 degrees stays the same size angle, but we're just going to convert it into radians. And notice that the degree in the numerator here and the degree in the denominator here will divide out, so my angle will not be in degrees, it will be in radians, which means I have a pi here. It's in terms of pi, or just a numerical value. So the 60 that goes into 180 3 times, and so we're just left with pi over 3 radians. So 60 degrees is pi over 3 radians. Notice I'm not writing the word radian after the pi over 3, and that's because if you see an angle in terms of pi, it's automatically assumed to be in radians. Same idea with the 135 degrees. We'll multiply by pi over 180. Again, degrees divide out. I'm left with an angle in radians only. So 45 divides into 135 3 times, and 45 divides into 180 degrees 4 times, and so 135 degrees is 3 pi over 4 radians. Now the 206 degrees here, that's not one of the special angles like 135 degrees or 60 degrees. That's called a special angle because it's a multiple of 45. So in this case, I'm just going to answer as numerical answer, not something in terms of pi. So when I multiply by the pi over 180 degrees, the degrees do divide out, so I have an answer in radians. But I would just go 206 times pi and divide by 180. And so now notice it says approximately. These were exactly 3 pi over 4, exactly pi over 3. This is approximately 3.6 radians. And I have a numerical answer here now, so I'll write the word rad so there's less confusion. Somebody doesn't think that I've just left the degree off and it's 3.6 degrees. It's 3.6 radians. Flipping over to the second page, in example 2 we're asked to convert to degree measure. And so 2 pi over 3 radians. In order to convert that to degrees, I'll multiply it by 180 degrees over pi. Notice that my pi's will divide out now, and so I have an answer left in just degrees. So the pi's divide out. Also 3 goes into 180 60 times, and so now I'm left with just 2 times 60, and so that's exactly 120 degrees. 1.62, notice it's not in terms of pi like the 2 pi over 3 was, so this is just going to be a numerical answer. So I'll multiply by 180 degrees over pi, and I'll just go 1.62 times 180 degrees and divide it by pi, and so that's approximately 92.8 degrees. Now the nice thing about measuring angles in radians is there's a very convenient formula, simple little formula, for calculating arc length, or partway around a circle. And that's what arc length is. And this formula says that the length of an arc, and lowercase a stands for the arc length, the length of an arc in a circle is equal to the size of the angle in radians only, multiplied by the radius of the circle. So arc length is the size of the angle in radians multiplied by the radius. There is another formula if the angle is in degrees. It's just a little bit different than this one. And so in this example we're asked to calculate the arc length. This is a 2.7 radian angle and the radius is 5 centimeters. And so I will plug in place of theta 2.7 radians, and the radius is 5 centimeters, and 2.7 times 5 is 13.5 centimeters. So it'll be 13.5 centimeters along there. So the arc length is 13.5 centimeters. Last example, we're asked to calculate the angular velocity in degrees per second and radians per second for this motor that's turning at 2,000 RPMs. So revolutions per minute, or complete all the way around the circle per minute, 2,000 times. So we need to calculate how many degrees are in 2,000 revolutions around a circle, and then also the radians as well. So to figure out how many degrees there are in 2,000 revolutions of a circle, I would take 2,000 and multiply it by 360. And so that's 720,000 degrees. So to calculate the velocity, velocity is distance over time. In this case, it's not distance as in how many meters or miles you've moved. It's number of angles in degrees that you have revolved through. And so the distance is 720,000 degrees, and we're asked in per second, so that's why the time is 60 seconds. 1 minute is 60 seconds. And so dividing that out, I get 12,000 degrees per second. That's the angular velocity. Every second this motor turns through an angle of 12,000 degrees. To calculate the size of the angle in radians, 360 degrees is a full circle revolution in degrees. In radians it's 2 pi. And so I multiplied 2,000 by 2 pi to get 12,566.4 radians. And so, same as before, velocity is distance over time, so I've revolved through 12,566.4 radians in 60 seconds. And so we divide that out, and so the angular velocity in radians per second is about 209.4 radians per second. And that's the end of the lesson.